Welcome back to another video. It is your favorite math professor, Dr. Tarcia Hubert here. And in this video, we're going to be talking about scatter diagrams and correlation. So let's jump right in and get started. So just exactly what is a scatter diagram? It is a graph that shows the relationship between two quantitative variables. Okay, remember what quantitative variables are. They measure quantity and they're measured on the same individual. And each individual in the data set is represented by a point. And that's how we create our scatter diagram. The explanatory variable is typically plotted on the horizontal axis and the response variable is plotted on the vertical axis. So recall what the explanatory and response variables is. The response variable is the variable whose value can be explained by the value of the explanatory or predictor variable. Okay. And so these are examples of scatter diagrams. They're just points in a graph. And we typically look for some type of relationship between our two variables. That's what we're looking for. And these are some examples of some relationships. So this is an example of a linear relationship. This is an example of a linear relationship. There is a relationship going on here, but it's non-linear. There's a relationship going on here, but it's also non-linear. And there is no relationship going on here. Whenever your points are just scattered all over, there's no relationship, all right? But if you can see, these are trending in some type of direction. And so these have relationships, but what we're going to be looking for are linear relationships. And we can see there's a linear relationship in these two, okay? Now, if the value of one variable increases and the other value of the other variable increases as well, we call that a positive relationship or a positive association. So as you can see, as these points are going up, as these values on the x-axis are going up, these values on the y-axis are going up. It's going up in a trending, increasing fashion. So we say there's a positive linear relationship here, all right? And vice versa on these. As the values decrease, these values decrease, all right? But we typically talk about it in an increasing fashion. Now, if the value of one variable increases and the value of the other variable decreases, this is a negative association. So as you can see, the line is trending. This is a linear relationship and it's trending down in a negative direction. So here we will say there is a negative association. And so we have a value that we measure called the linear correlation coefficient, also known as the Pearson product moment correlation coefficient. And this measures the strength and direction of the linear relation between two variables, okay? So there is actually a number that we can get that can determine whether there is a linear correlation or not. And it'll also determine how strong their relationship is and whether it's positive or negative, all right? We use Greek letter rho to represent the population correlation coefficient, and we use the letter R to represent the sample correlation coefficient. In this video, we are only going to calculate R, which is the sample correlation coefficient. And here is the formula for that. You take the sum of each data point minus the mean of that data point divided by the sample standard deviation of those data. And you do that for each variable because remember this time you have two variables. You have a set of x's and a set of y's. So you'll do that for each variable. You'll multiply those, take the sum of all of that and divide it by n minus 1, where n is your sample size, okay? So we're going to go through and work an example and do this, calculate this step by step. But before we do that, there are some properties of linear correlation coefficients that I want to talk about. And the first is that the linear correlation coefficient is a number that's between -1 and 1. All right, it'll never be outside of those bounds. It'll always be between -1 and 1. If R is positive 1, then there is a perfect positive linear relation between the two variables. If R is -1, there's a perfect negative linear relation between the two variables. The closer R is to positive 1, the stronger the evidence is of a positive association, and vice versa. The closer R is to -1, the stronger the evidence is of a negative association between the two variables. If r is close to 0, then that means there's little or no evidence that exists of a linear relation between the two variables. So r close to 0 does not imply no relation, it just implies no linear relation. So remember those graphs I showed you earlier, there can be other relations, but there just may be, it might not be a linear relation. So r is only measuring a linear relation, so keep that in mind. The linear correlation coefficient is unitless, so it doesn't matter what the units are for x and y, those don't play a part in the interpretation of r. And then the correlation coefficient is not resistant, meaning that those outlier variables can affect the value of r. It is not resistant. And it says, therefore, an observation does not follow the overall pattern of the data could affect the value of the linear correlation coefficient. All right. So those are 8 properties of the linear correlation coefficient. And here are some more sample scatter diagrams. This is an example of r equal 1. That's a perfect positive linear relation. This is an example of a strong positive linear relation. It's not a perfect line, but you can see the scatter diagram that the points trend up in a linear fashion. This one is moderate. It's trending up in a linear fashion, but it's not really close to a line, but you can see a linear line trending in that. So we say that's a moderate positive linear relation. This is a perfect negative linear relation with r equal -1. This is a strong negative linear relation with r equal -0.9. It's going down, so it's a negative association. This one has a negative association. It's not as strong as this one, but you can see it is trending down in a negative direction. This one has no trend in it, so this would be a r close to 0. There is no type of relation here. And then here, this one has a relation, but it's not linear. So this one will also be close to 0. This follows what we call a parabola or a parabolic path. So this looks more like a quadratic relation, which we're not talking about now, but just so you know, it's in the shape of a U, an upside down U, if you can see it. So there's no linear relation there. And then you can test for it. There's a way to test for a linear relation, and that what you do is you take the absolute value of the correlation coefficient and you compare it to what's called a critical value. And a critical value is determined by using a critical value table and the sample size, all right? And I'll show you the table on the next slide. But if the absolute value of the correlation coefficient is greater than that critical value, then we say there exists a relation, a linear relation between the two variables. If it doesn't, if it's not bigger than that critical value, then we say there's no linear relation. It doesn't mean there isn't a relation between the two variables. It just means there's no linear relation. And here's our critical value for correlation coefficient. And it goes up to sample size 30. For anything, any samples bigger than size 30, you would just use the critical value for 30. And vice versa. Anything less than 3, you will use the critical value for 3. So here's an example. What we want to do is we want to draw a scatter diagram of the data. Then we want to compute the correlation coefficient, which I'm going to show you kind of semi how to do it by hand, because I'm still going to use Excel, but I'm going to go through step by step. And then we're going to use the critical values to determine whether there is a linear relation between X and Y. All right. So what I'm going to do is I'm going to take this data and I'm going to put it in an Excel spreadsheet. I'm going to list all of my X's and all of my Y's. And also, we're going to go through, I say do it by hand. This is how you compute it by hand. Remember, you use this formula divided by n-1. So I'm going to show you how to go through and compute each of these, but it's still going to be in Excel, okay? Okay, so I'm in Excel, and what I've done is I've created a list of my X, and I've typed them in here, and my Y, and I've typed those in here. All right, and the first thing I need to do is find the mean and the standard deviation for each of these data sets. So remember, in Excel, you can find, and I just have them listed in no particular order. I have the standard deviation of X first. Remember, you can find the standard deviation in Excel by typing equal and ST. And I want to do the standard deviation of the sample, so that's the .S. I'm going to double click on that and I'm going to highlight my x values and close the parentheses, and that gives me the standard deviation of x, okay? And then I can find the mean of x by doing equal and typing in average. It pops up and I'm going to double click on average and I'm going to highlight my x values because that's what I want to take the average of. Now for SY, I want to take the standard deviation of y. So again, I'm going to type in equal. I'm going to type in ST and I see standard deviation pull up, and I want to do the standard deviation of the sample. So I click the one with the dot S and I'm going to highlight my y data values. Close the parentheses and hit equal. Now I want to take the mean of y, so I'm going to hit equal and I'm going to type in average. I'm going to double click average and I'm going to highlight my y values because I want to take the average of y. So what I have here is the standard deviation of my x's, the mean of my x's, standard deviation of my y's, and the mean of my y's. So now in this row, I want to take each data point minus the mean of that data set divided by the standard deviation. So I'm going to type in equal, I'm going to do parentheses, I'm going to do the data point minus the mean of x, which is 5. I'm going to close the parentheses and I'm going to divide it by the standard deviation of x, which is 2. So I have each data point minus the mean of that data divided by the standard deviation of that data. And I'm going to hit equal, and I'm going to click on this cell and click the corner and drag it down. And what it does is it applies that formula to all of my x values. And I'm going to do the same thing for y. I'm going to hit equal. I'm going to take my y point. Oh, I'm going to put parentheses first. Now I'm going to take my y point, subtract it from the mean of y, which is 11, and then divide all of that by the standard deviation of y, which is 6. Now I have to put this top part in the parentheses because if I don't, it's only going to divide the 11 by 6. And I want it to divide the whole numerator by 6. And I'm going to hit equal, and I'm going to drag that down. All right. Now I'm going to jump real quick because I was supposed to do a scatter diagram first. So what I'm going to do is highlight the x and y's. I'm going to go up here to insert, and I want to go to charts, and you see the scattered right here. I'm going to click here and click the scatter diagram. And as you can see, this is what my scatter diagram looked like. It looked like it's trending up in a positive direction. So what I want to do is confirm that by my calculations, okay? So that's how you create the scatter diagram. So now for this column, what I want to do is I want to multiply this value times this value. So I'm going to hit equal, this, my multiplication symbol, and this one, and hit enter. I'm going to click on the corner and I'm going to drag that down so that it can apply that to each column. So I multiply this times this, and here I want to take the sum of those. So I'm going to hit equal sum, and I'm going to highlight those values, close the parentheses. Now my n, I have 5 data points, so n minus 1 is going to be 5 minus 1, which is 4. And so now to calculate the correlation coefficient, I'm going to do this value, the sum, divided by my n minus 1. And that gives us our correlation coefficient. All right. Now I want to go back to my critical values table. So I'm back in my critical values table, and my n was 5. So I want to take the critical value for n equal 5, which is 0.878. So I've typed in my critical value here of 0.878. And what I want to look to do is see if my correlation coefficient is bigger than my critical value. And it is. And since it is bigger, we would say there is a linear relation between those 2 points. All right. And really quickly, I want to show you that you don't even have to do all of those steps. You can just type in equal and type in correlation, C-O-R-R-E-L, double click it, highlight this first column, comma, highlight this second column, close your parentheses, and it'll calculate that correlation coefficient for you, which is the same value we got here by going step through step. So this is how you calculate the correlation coefficient and how you use the critical value to determine if there's a relationship or not. If there are any questions, please don't hesitate to put them in the comments. Thank you for watching, and I will see you in the next video.